So, good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we start the last chapter that we're going to be covering this quarter. That's chapter 11. And we're going to take a look at 11.1. So let's get started. Okay. We're going to talk about a new operation this morning, and that is called composition. Okay, we've got addition, subtraction, multiplication, division, taking roots, taking powers, all of that stuff. Now, the symbol for the operation composition is a circle, and we'll talk more about that here in a minute. Okay, let's say that we have the following. We have f of x equals 2x plus 1, and g of x equals x squared minus 1. And we are going to find f composed with g of 2. Now, it looks like fog. Maybe it'll feel like fog. But that little circle between the f and the g, that's not a 0 or an O. That means we're going to take f composed with g of 2. Now, f composed with g means that we're going to find f of g. So f composed with g of 2 is going to be f of g of 2. What we're going to be doing today, it's not complicated, but you've got to get used to how things work, to the order in which things happen. Okay? So the next thing I'm going to do is figure out what is g of 2. Well, g of 2 is 2 squared minus 1, which is 4 minus 1, which is 3. So now that is going to go back in the place of g of 2. So now I have f of 3. How do I find f of 3? 3 goes in here. Okay, so f of 3 would be 2 times 3 plus 1, which is 6 plus 1, which is 7. So f composed with g of 2 equals 7. Now, it seemed like a lot happened there, but it really wasn't all that much. We took 2 and stuck it in for g of x, got the result, stuck that in for f of x. Okay, do you have any questions so far?
So far, no.
Okay, here comes another example. Let's take those same two situations. F of x equals 2x plus 1, and g of x equals x squared minus 1. Now let's find g composed with f of negative, of 2 again, sorry. Yeah, I looked at the wrong thing here. That's also of 2. Okay, so we did f composed with g of 2. Now we're going to do g composed with f of 2. So g composed with f of 2 is the same thing as g of f of 2. So now I need to find f of 2, which is 2 times 2 plus 1, which is 4 plus 1, which is 5. So g of f of 2 is g of 5, and g of 5 is 5 squared minus 1, which is 25, minus 1, which is 24. So g composed with f of 2 is 24. I want you to notice that the first one, F composed with G of 2 was 7, G composed with F of 2 is 24. So in general, the operation of composition is not commutative. There are cases where it is, we'll be looking at those later, but in general, it's not true. So whereas like addition and multiplication are commutative, composition is not commutative in general. Do you have any questions about this problem?
No.
Okay, another example. Let's see here. Let's take, again, f of x equals 2x plus 1, and g of x equals x squared minus 1. We're going to find f composed with g of 2x. Okay, so this is equal to f of g of 2x. So now I need to find g of 2x, which means I put 2x in the place of, or substitute it for, x in the g of x function. So I get 2x, the quantity squared, minus 1, which is 4x squared minus 1. So this goes in the place of that. So now I have f of 4x squared minus 1, which now that goes up here, 2 times 4x squared minus 1 plus 1, which is 8x squared minus 2 plus 1, which is 8x squared minus 1. So there's your final answer. So f composed with g of 2x equals 8x squared minus 1. If I'm going too quickly, please let me know. I'll slow down. Anyway, you okay with this?
Yeah, I'm okay with it.
All right,
Yeah.
Greg, you okay?
I'm following along.
Okay. Let's see here. Here's some new ones. Let's say that f of x equals 3x minus 2, and g of x equals x squared plus x. Let's find f composed with g of 4. So that's equal to f of g of 4. G of 4 is 4 squared plus 4, which is 16 plus 4, which is 20. So f of g of 4 becomes f of 20. F of 20 is 3 times 20 minus 2, which is 60 minus 2, which is 58. So f composed with g of 4 is 58. Questions there?
No.
All righty. Let's take a look at, let's see, g composed, well, wait, I need to write down what the functions again. Sorry. F of x is 3x minus 2, and g of x is still x squared plus x. And let's find g composed with f of x, which is g of f of x. Well, what is f of x? F of x is just 3x minus 2, right? So that's going to go in there. So now we're going to get g of 3x minus 2, which is 3x minus 2 squared plus 3x minus 2, putting all of that up here. So now I've got 3x minus 2 times 3x minus 2 plus 3x minus 2, which is 9x squared minus 6x minus 6x plus 4 plus 3x minus 2, which is 9x squared. Let's see, minus 12 plus 3 would be minus 9x plus 2. So g composed with f of x equals 9x squared minus 9x plus 2. Okay with that?
Yes.
Now, what's this all about? Well, this class, Math 95, is on the STEM pathway, which means that if you continue on in your math, you ultimately, depending on your ultimate pathway, you may end up taking calculus. Okay, I don't know if what you two are going to do, but in calculus, sometimes there's a very complicated function that we have to deal with and do some things to. And right now we're looking at composition, which is taking two functions and combining them into a combination. There's a way to sort of decompose and take a complicated function and pull it apart into two simpler functions, which we can then deal with separately. So this is kind of the start of that process, among other things. So if you're thinking, what are we going to do with this? Well, again, it depends on if you go on and take calculus, or I don't remember if in the business calculus sequence, if you need this or not. But anyway, that's what this is about. Okay. Let's see here. How about if f of x equals 1 over x and g of x equals 1 over x squared? Let's find g composed with f of 1/3. Okay. So that's equal to g of f of 1/3. So now I need to find f of 1/3. F of 1/3 is 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is basically 3. So f of 1/3 equals 3. So that's going to come back over here. And now we're going to have g of 3, which is 1 over 3 squared, or 1/9. So g composed with f of 1/3 is 1/9 for these two functions. All righty with that?
Yep.
Yeah.
Okay. Let's see here. Let's take that same scenario where f of x equals 1 over x and g of x equals 1 over x squared. And let's find f composed with g of 5x. So that's equal to f of g of 5x. Well, let's see. G of 5x would be 1 over 5x, the quantity squared, which is 1 over 25x squared. So all of that goes to replace that. So now we have f of 1 over 25x squared. Now we're going to take this and plug it in here. So that's equal to 1 over 25x squared, which is 1 divided by 1 over 25x squared, which is 1 times the reciprocal of 25x squared over 1, which is 25x squared over 1. So f composed with g of 5x equals 25x squared. And we get that. All righty. Going on. Let's have h of t equals the square root of t plus 3, and k of t equals t minus 5. So h composed with k of 18 is h of k of 18. K of 18 is 18 minus 5, which is 13. So H of K of 18 equals H of 13, which is the square root of 13 plus 3, or the square root of 16, or 4. So H composed with K of 18 equals 4. All right there.
Yeah.
Okay. Let's take H of T equals the square root of T minus 3 again. And K of T equals T minus 5. And let's find K composed with H of -2, which is K of H of -2. Oh, you know what? I see. I copied this wrong. This is supposed to be a plus sign. Good thing, because otherwise we couldn't do this. So H of -2 is the square root of -2 plus 3, which is the square root of 1, which is 1. So this becomes K of 1, which is 1 minus 5, which is -4. So K composed with H of -2 equals -4. Okay. Now, earlier I mentioned that the operation of composition was not commutative in general. And we already did that with one example, but we're going to do it again here. So let's say f of x equals x plus 1, and g of x equals 2x minus 5. We're going to show, so show that f composed with g of x does not equal g composed with f of x. Okay, we're going to show that. So let's find f composed with g of x, which is f of g of x. G of x is 2x minus 5, so this becomes f of 2x minus 5, which is 2x minus 5 plus 1, or 2x minus 4. So f composed with g of x equals 2x minus 4. Okay? Now, I think what I'm going to do, get my eraser to work, is I'm going to, this, well, yeah, which equals 2x minus 4. See if I can put the second half over here. So now let's find g composed with f of x, which is g of f of x, which is g of, well, f of x is x plus 1, which is 2 times the quantity x plus 1 minus 5, 2x plus 2 minus 5, 2x minus 3. Well, 2x minus 4 doesn't equal 2x minus 3. So this shows that composition in general is not commutative. Now, what we're going to be looking at tomorrow, we'll be looking at some specific cases where composition is commutative, but only in certain contexts that we will be discussing tomorrow. Well, that's all I've got for you today. So do you have any questions about clarification of anything?
No.
All righty. Well, then we'll call it quits for the day, and I will stop the recording.